Okay, so this is officially the last video that you need to watch for how to sketch transformations of sine and cosine functions. It's going to be a beast of a video. I suggest you either look at the other videos because I'm going to be not explaining what some of the work is. I am just going to jump into it. I'm assuming that you know how to do the other work. And let's go ahead and let's do this. Okay, so the first thing that I'm going to go ahead and do is amplitude is equal to 2 because that's the number right there in the front. Our midline is represented by that -3, so that means the new midline is going to be down at y equals -3. Let's see what else. Now we can go ahead and do our start and our end. We do that by creating two equations. One is equal to 0, and the other one is going to be equal to 2 pi. And this is where the quote-unquote hard work is because we have a little bit of a hard time with this. So first step, isolate the variable by subtracting pi over 6 on both sides. That is equal to 0 because it's inverse of each other. So 3x is equal to negative pi over 6. Notice how it's negative, and since we're dividing by 3, all that's going to do is just make it into a smaller fraction, so it's going to stay negative. So we already know that the phase shift, it's going to go to the left because it is a negative number. So we're going to divide by 3. I'm going to go ahead and do that like that one. And then x is equal to, keep, change, flip. We're going to do that one times, actually, you know what? I shouldn't put the little times there. I should put the little dot for times. Flip, we're going to do 1 over 3. Sorry, that's times. And then we'll get negative pi over 18 because we are multiplying. You can put a 1 there if you want with the pi. So this right here is my start. Okay, so let's go ahead and write that start. All right, and you guys are going to need more space, but I still didn't draw it correctly or write it. So let's go ahead and let's shift this over and let's figure out where the end is going to be now. Okay, so we have 3x plus pi over 6 is equal to 2 pi. Solving for this, minus pi over 6 minus pi over 6, and aha, we are doing now fractions where we need to get common denominator. So I'm going to go ahead and write this side over here. It'll be 2 pi minus pi over 6. I need to get a common denominator. That's a 1, that's a 6, so that means I'm going to multiply this one by 6 to get it to match. So let's go ahead and let's do that. Times 6 times 6. So then my new numbers will be 12 pi over 6 because 1 times 6 is 6. After that, I can go ahead and subtract. If you want, you can put the 1 there just to help you out. 12 pi minus 1 pi is equal to 11 pi. When we subtract fractions, we keep the same denominator. And after that, we could go ahead and divide by 3. Some of you are probably getting to the point where you could go ahead and like not have to write it with the divide sign. You can already jump into the keep, change, flip. So we're going to go ahead and do times 1 over 3. And then we go ahead and we just do 11 pi over 18. So this right here is considered to be my end. Notice how it goes from negative pi over 18 to positive 11 pi over 18. I am not going to talk about what the period is, just understand that for right now. And so let's go ahead and let's see how to graph this, or sketch. I should probably say sketch. So let's see. A is 2 and D equals -3. Okay, so let me go ahead and let's write that over here. A is equal to 2. D is equal to -3. We have our start, we have our end. 11 pi over 18. I don't even remember. Negative pi over 18. And then we are working with sine. Awesome. So sine. So you guys remember, that looks like that with the midline in the middle. Okay, so let's think about, how to be smart about this. So the start is negative pi over 18. Okay, so I need negatives on my x values, and then I need a positives here. the midline is at -3, and it's going to go up and down 2 from the midline. So I need to go ahead and let's draw it like that. This is the XY axis, okay? Let's do our midline first because that's always the first thing we do. At -3, okay? And so then I can go ahead and draw my midline. It just helps me visualize, that straight line, okay? And then we know sine starts on the midline, so that's good. So the dot I'm going to do is on the yellow line, and basically it's going to be this right here, -pi/18. It's a negative, so I'm just going to go ahead and do -pi/18 over here. So that means my dot is going to go somewhere right there. And then it's going to end at 11pi/18. So that means I'm just going to put 11pi/18 here. Okay. And then we can go ahead and draw our next dot right there. And all I have to do now is really just sketch it out. Remember, these are sketches. If you want to get super detailed, super know what these numbers are, get this like units right here totally correct, yeah, this is not the right video. You need to go to another one. But for right now, since this is just a sketch, boom. I know that looks really bad because it has to be half and half. So it'll look something like that. Who knows what these numbers are? Who knows? But there you go. That would be a super rough sketch. Okay. It's a piece of a problem, I will tell you that. But if you look at all the work, it's just super repetitive. The only hard part, I believe, is like this part right here with the fractions. I mean, but then does that really mean you don't understand the trig part, or does that mean you're having trouble with the fractions? Just really think about that. I have no problem like trying to help you out with the fractions because you already know what the steps are. But in order for me to help you with the fractions, you have to at least get to that part by yourself, okay? So there you go. That was one example. I think I said in the beginning of the video to be 1, but yeah, it was a little bit faster than I thought. So let's go ahead and do the next one. Let's go ahead and stuff from before. Our A is equal to, not the amplitude, but just the A based off of the equation. Ooh, nice. It's negative now. We haven't seen a negative one. D is equal to the number that is separated from the cosine or sine. If you notice, the 1 is separated from it. It's not next to it being multiplied. It's not inside the parentheses. So now, that 1, is it positive or is it negative? Well, there's no negative in front of it, so that means it's a positive 1. And then we go ahead and, yeah, that's pretty much all we could do. Now we have to think about the start versus the end, and then the phase shift. Like this move to the left, to the right, and that all talks about the start, okay? So that's what you would have to do right there for phase shift. So we already got that out of the way. Let's go ahead and let's do our equations. So once again, I'm going to write it as x because, why not? Whatever. So equals 0. That's the first one. Let me actually do the work before I write the other one because I think I've been erasing it every single time. So minus pi on both sides to isolate the variable, which is x, by the way, not pi. Pi is just a number. Negative pi multiplied by 2 on both sides. So we get x is equal to -2 pi because we're multiplying. So this is considered to be the start. If you notice, it is negative. Okay, it is negative. So that means we move to the left 2 pi. Sorry, that's the start. So let me actually write it before I move on. So -2 pi. And let's go ahead and let's figure out where is it going to end. The 1 cycle we're trying to draw. So let me go ahead and do the exact same equation, but now instead of it being equal to 0, it is equal to 2 pi. Remember, that's sort of like the what we're trying to do. We're trying to figure out where is it when it's supposed to be 0, and when is it when it's supposed to be 2 pi. So we could go ahead and let's do the work. We do minus pi on both sides. That is equal to 0 because they're inverses. We get x over 2 is equal to, if you put a 1 there, that'll be a little bit easier for some of you. 2 pi minus 1 pi is equal to 1 pi. Then we go ahead and we do times 2 on both sides since right here is being divided by 2. So opposite of that, inverse is multiplied by 2. So we get that to equal 1 there. X is equal to 2 pi. So this is considered to be our end. Okay, so let's go back and fill in that information. So it'll stop at 2 pi. So it actually wasn't that bad, and we pretty much already have everything we need to do to graph. So let's go ahead and let's do that. So let me just try to remember these, and let's put the information here. So A equals to our D, our start, our end, and then if you really want to think about it, you could do phase shift. Okay. So I remember this one is left 2 pi, so that means the start is negative 2 pi. The end is, sorry, that looks really bad. The end is, okay, 2 pi as well, I believe. Yeah, I don't know why that looks so ugly. Let me just start all over. Okay, so the start is negative 2 pi. The end is positive 2 pi based off of our work. Let's see, the amplitude, no, sorry, the amplitude, the A is equal to negative 4. The D is 1, positive 1, and we're talking about cosine. So the A is equal to negative 4. This is positive 1, and we are talking about cosine. Yes, we are. Okay, just had to make sure. Okay, so let's go ahead and let's think about how we can draw this this graph. Remember, it's a quick sketch, so it's going to go from negative 2 pi to positive 2 pi. So it needs to be centered. We're going to go up 1. So you know what that actually means is I need to bring down this x-axis here just so I can have room. And then our A is 4. So yeah, that's going to be, we're going to see if this fits. Okay, so let's do 1 right there. That is going to be considered my midline. And now let's go ahead and let's really think about it. This one is cosine, so it's going to look like that with the midline straight down the middle. Okay, and so then we need to start, oh, well, actually it's a negative, so this is the positive cosine, so therefore we need to do the inverse one, so the one that looks like this. So the one we're actually going to try and draw is this one here, okay? Because it is a negative sign, okay? I totally forgot about that. I just noticed it right now. So what that means is that we need to figure out where this dot is going to go. This one right here, the first one. So we know that it goes below the midline, and we know that it's 4 spaces away. So I need to count 4 spaces away from 1. So we can go to 0, that'll be 1 space, and then negative 1, negative 2, and then negative 3. So that right there is where my dot is going to go because it is 4 spaces away from the midline, right? If you really need to, we can count it, right? 1, 2, 3, 4. Okay, so my dot goes here. Oops, sorry, it will not go there because I totally forgot about our phase shift. So our phase shift is now going to tell us where to actually draw our dot, which is going to be at negative 2 pi. So I need to go out to negative 2 pi, and I'm going to count by pi's. So let me actually do that in red because it's going to be easier. So this is going to be negative 1 pi. That's going to be negative 2 pi. Okay. And then it's going to go out to 2 pi. So that's 1 pi right there. And then let's do 2 pi right there. Okay. And so now, in order, because I need the space, I'm going to go ahead and erase this part where it's showing me the negative one. I will redraw it right there, so don't worry about it in the empty space. So we know it has to look like this because it is considered to be negative. Okay. Just draw that little arrow. All right, so we go ahead and at negative 2 pi, so right here where it says negative 2 pi, I need to go down to negative 3. Okay, that is technically this point right there. Okay, so now let's go ahead and we know it's going to end at positive 2 pi, which is this point. So I'm going to go ahead and draw my point here. Now, the only thing I haven't calculated is basically how far up it's going to go. We only did how far down. So if we're going to move 4 spaces, right? 4 spaces above our midline, since we remember that that's where this peak is going to be. We need to basically go up 4 from the midline. So it's already at 1, so 2, 3, 4. Some of you are going to stop right there. You're going to think that's where it's supposed to be, but no. If you really think about it, that is only 3 spaces above the midline. You need to go 1 more, okay? So we need to actually go out to 5. Really think about what it means to be above the midline, okay? If the midline is 1. And so now the last thing we need to do is basically just draw my y. And yeah, this doesn't look like, super drawn to scale, but you just have to get the idea that it's going to go something like that. Okay? Yeah, this bottom part is totally, well, no, actually it doesn't look that bad. It didn't go out to the 5. So you know what I'm going to do? I'm going to do the super lazy way of fixing it. Boom, that's 5 now. Okay, but if you have graph paper, this makes it way easier. I should have probably put graph paper here, but let's be honest, even if I did have it, they wouldn't come out perfect anyways. So there you go. This would be a super rough sketch. Now, for those of you guys that really, really want to think about it, period. Okay, how long does this take to repeat? So if it starts at negative 2 pi and then it starts repeating at positive 2 pi, you need to think about, well, what's the distance, right? Because that's what we're actually trying to figure out. What is the distance between negative 2 pi to 2 pi? Well, if we just ignore the pi, right? Let's just do that for right now. Let's just ignore the pi. Then you're actually talking about going from negative 2 to 2. So from negative 2 to 2. Think of a number line there. How many spaces would you go if you're going from negative 2 to 2? We're talking about a distance now. So that is actually going to be 4, right? Because you go 1, 2 to get to the 0, and then from the 0 to the 1, and then there. So you actually take 4 spaces. And since we're talking about pi, we're talking about 4 pi spaces. So it's going to take 4 pi to actually repeat. So what this means is that if I were to think about the parent function of cosine, right, the parent function, this graph right here, the green one, the one we just drew, it's like if you're stretching it out, because the parent function always has a period of 2 pi, but yet this one was a 4 pi, so it's being stretched out.